Okay. So today we are talking about the virtual networks and we call it a theory of virtual networks. So you are going to understand what is virtual network means and what are all the features we have with respect to the virtual network and how much it is important. Okay. So if you ask me the definition, so virtual network it is nothing but it is the network services, or we will call this virtual network as the logical representation of your network in the cloud. That is called as virtual network. Okay. So there are many other services available in the network. Okay. The first one is virtual network, and within that you have IP addresses. Okay. When you create the network, you should have the IP address also. Correct. Now, there are two types of IP addresses are there. You already aware of it. One is private network, another private IP. Another one is public IP. So private IP means it is a secured one. You don't have to pay for those IP address, and it has not got any exposure to the external world. Whereas public IP means it is the chargeable IP address. You have to pay for it, and it is exposed to the internet, and there is more risk also. That is the IP addresses. Okay. And many other services like load balancers. So load balancer means it is one of the network resource to increase the high availability of the application or increase the availability of the application. We will create the load balancers. And then application gateway. So application gateway, it is the layer 7 load balancer. So the load balancing happens at the application level. Okay. The application URL redirection, everything happens at the application gateway. And the traffic manager, that is also a network resource. This traffic manager will do DNS level load balancing. So based on the DNS, it will balance your load. Say for example, today you are accessing the Facebook application by being in India. So tomorrow on a business trip, you travel to UK or USA. There, when you type www.facebook.com in your browser, the browser DNS detects that you are not in India and you are in USA. Instead of sending the request to Indian server, Facebook server, it will send to the USA Facebook server. That happens using the traffic manager. There are multiple things are there. Anyway, I'm going to explain each and everything. The next one. Okay. The next one is network security group. This network security group is very important actually. So this network security we will also call it as NSGs. NSGs is nothing but it's a firewall kind of a thing. So in the cloud, there are two levels you can apply the network security group. One is at the network interface card of the VM. So if you create a virtual machine, that virtual machine will have a network interface card. We will call it as NIC card, where you will give the IP address and it will enable the communication. So since we are keeping this workload somewhere in the cloud data center, somewhere in the vendor data center, maybe Azure or AWS or Google, we wanted to ensure high security for our applications workloads. So hence this network security concept came. You can apply the NSG at the two level. One is at the network interface card level, another one is at the subnet level. Okay. So you can control your incoming traffic and you can define what outgoing traffic should be there. Everything can be controlled at the network security group level, and that is applicable at two level, subnet and network interface card. And you will also have the peripheral firewalls also. So peripheral firewall means at the edge of your network. Say for example, you have a connectivity between your on premises and the cloud using express route. So one firewall at the cloud will be there. Maybe it is an Azure firewall or Palo Alto or whatever firewall. You can use that firewall and control the traffic which is going inside your Vnet in the cloud. And at the on premises, you may have some physical firewall. There you will define and control what traffic should be coming in or what traffic should be going out via that firewall. So firewall is also a networking device, security device in fact. Okay. And force tunneling. Say for example, you have multiple data centers, and that multiple data center has got multiple nodes. You can define my source A and source B should go via which tunnel. So instead of, say for example, if you want to go from Majestic to Mysore, there are multiple ways are there. Okay, one is via your Kengeri, Ramnagara, Mandya. Okay, another one is also there. You can go to Kunigal. From Kunigal, you can take left via Mandya, Nagmangla. You can also go to Mysore. Correct, na? So in the forced tunneling, what you will do? You will tell your traffics or the network devices any traffic that is wanted to go to the destination, you should always follow this tunnel. That is called as forced tunneling. Okay, the packets are forced to use the same tunnel, the specific tunnel, that is called as forced tunneling. Okay, then we have regional vnets. Okay, so within the vnet, say for example, you are going to create two virtual networks within the Western Europe region. By default, no two VNets will have the communication, because VNet A is a separate network, VNet 2 or VNet B is a separate network. Even that is the same thing in the on-premises also. Imagine you have two networks, building 1, building 2. If you don't put the router in between and enable the routing between network A and network B, by default there is no communication. The same fashion applicable for the cloud also. Okay, in the cloud, what happens when you create two virtual network, the traffic which is private will not have communication with the external or the another network. So you have to create some peering actually. So you have to enable the connectivity between two different VNets, that is called as VNet peering, and the communication between two different VNets, it is private in talk. So it is not exposed to the internet, everything is end-to-end secure, and it is a private talk. Okay, that is called as regional VNets. Okay, so if you create two VNets between the regions, say for example, you have to create one region, one VNet in the Western Europe, another VNet in the Northern Europe. Even that case also, we use the Microsoft backbone network. We will do the global VNet peering. Even that is also a private network only, but that will use us our Microsoft backbone network. The Microsoft backbone network means we have this 52 regions, right? We have this 52 regions in the Azure, and Microsoft has laid down the cable between among all the regions, 52 regions. All the data centers are interconnected. They have laid down their own cables in the ocean, in the desert, or whatever it is. Okay, so they have internally connected, and the traffic is a private traffic. Okay, that is called as regional VNets. And the cross premises network. So today you have your physical office in India, Bangalore, and you have your some of the workloads in the cloud. Correct, right? And today you are working from home and you wanted to connect your office network. Okay, or you have two different Azure subscription with two different regions. That time we will use different connection type. So from your home to your office network, when you try to establish the connectivity, that is called as point to site. Or if you have two different locations, say for example Bangalore and Hyderabad, or Bangalore and cloud, there we use the site to site. Or two regions, Western Europe, Northern Europe, if you don't want to use Microsoft backbone, if you want to have a dedicated channel, that time you can also use site to site. And express route between your on premises and your cloud, we will buy the express route connectivity. Okay, that is the connectivity types. So these are all the things which are comes under network resources. Okay, now let us understand how the network architecture should be there in the cloud, or best practices. No matter whether it is cloud or no matter whether it is on premises, when you have multiple things, you should always have this hub and spoke model. But especially in the cloud, because cloud is somewhere you are in the third party vendor data center, you are deploying the workloads, it is important to control, or it is important to safeguard your workloads. That is why the best practice is to have the hub and spoke connectivity. Say for example, you have your multiple offices. You have Hyderabad, Bangalore, Mysore, Chennai. You have 4 offices. Not all the 4 offices are should be connected to cloud. So what you will do, all these 4 offices should talk to one point. Okay, and that particular network have got connectivity between multiple regions in the cloud. You can see here, you see here, this is your on premises, this is your on prem. What I was talking, the India, I mean within India, Mysore, Bangalore, Chennai, and Bangalore. Okay, you see here you have a express route connectivity. So this is the vendor will provide your express route, either it is Reliance or Tata, Airtel. They will give your their express route connectivity. They will put some boxes here, some network boxes that we call it as mugs actually. So here also they will put some software mugs actually. They will establish the connection. Say for example, my private network here, it is 172.16.00/16, and here it is 192.168.00/16. So it is my /16 network. So I have around 65,000 IP address here. Here also around 65,000 IP address here. I can further classify it into small subnets. I can create subnets here. See, and within the cloud, if I talk about the cloud, in the cloud, what you have to do, you have to separately, you have to create one Vnet here. Okay, and this is called as gateway subnet. This subnet will only have the connectivity between the on premises. And if you see, this is subnet 1, this is subnet 2, this is subnet 3. So if subnet 2 want to establish some connection between the on premises, what it will do, it will talk to the subnet 1, and subnet 1 will facilitate the connectivity to the on premises. So it cannot directly talk to the on premises. There is no separate channel between your Vnet subnet 2 to the on premises network, because this is called as hub and spoke. So this subnet 1 act as a hub, and these the small Vnets and subnets which are having the peering here, okay, they will called as spoke. So hub means only hub will have the connectivity to the on premises, and whatever spokes, if the spokes wanted to have the connectivity, or if they want to talk anything with the on premises, they will always reach the hub, and hub will facilitate the connectivity. This is called as hub and spoke. Okay, and if you see the Vnet representation, this is called as Vnet. See here, it will be like this. This is the representation of the Vnet. Okay, and each and every Vnet, if you see subnet level I was referring na, so I have kept my jump box here. Say for example, you are on premises, you are there, and you want to use your cloud servers. What they will do, they will create one jump server in your hub Vnet. You will log in from this server, take the RDP of this jump box, and by logging into this jump box, then you will access the workload. Say for example, if it is your SAP production, this is your SAP non-production. If you want to access SAP production, again from this jump box to this jump box you have to log in, again from this jump box to this jump box you have to log in, and from this jump box all the SAP production will be accessible, and from the below one all the SAP non-production servers will be accessible. So here there is no direct connectivity. Okay, to reach to the this jump box, first of all you have to prove your identity here. You have to enter your username and password here. Once you enter your username and password, you have to log into this computer. Again you have to prove your identity here. From here again you have to log in here. You have to prove your identity here. So it is increasing your security. I know it is administration burden is high, but since we are storing all the workloads in the external vendor data center, it is always important to ensure the security of our applications. If applications itself is not working, our business will not be there. If there is no business, a company will not be exist. Correct? Na? They will go bankrupt. So it is important to always have the high security or a well framed architecture for your applications. Okay. This is the hub and spoke model I wanted to explain. Okay. Now let us talk about the Vnet specifically. Okay. And one more point I left here. If you look at here, for the on-premises, I have written the IP address as 172.16/16, and for cloud I have written 192.168.0.0/16. So here a best practice what they will tell, you should both the on-premises and the cloud, there should not be any overlap between the networks. That is why I have selected the entirely different class. Okay, for the on-premises class B, for the cloud I have selected class C. Okay, so depend upon the requirement you can select. If you need more number of network, then according to the classes you can select, but you should not use the same network like 172.60.0.0/16, and here 172 you should not use at all. Okay, because it is not recommended. There should not be any overlap between the networks. So here let us talk about the Vnet specifically. Okay, I already told you no two Vnets will have the communication by default. Say for example, it is Western Europe. Imagine it is Western Europe. Even though it is the same region, each and every Vnets, each and every Vnet is isolated. So if you create a Vnet, say for example, this is 172.16.192, 192.168.0.0/24, and this is 192.168.1.0/24. See, both are different network. Here 0.0/24, here 1.0/24, both are different network. If your IP address of this computer is 0.1 and this is 0.2, they will have the communication by default. But if 0.1 wants to talk to 1.1 or 1.2, there is no default communication. Then if I want to establish the communication between two different VNets, I have to create virtual network peering. This is called as peering, VNet peering. Okay, so this VNet peering should be always transitive. Transitive means VNet 1 can talk to VNet 2. Simultaneously, VNet 2 can also talk to VNet 1. But the peering you have to specifically mention. It should be transitive or non-transitive. Transitive means both the VNet should have the communication each other. Non-transitive means only VNet 2 can talk to VNet 1, but VNet 1 cannot or should not talk to VNet 2, or one-way communication we call it as. That is called as peering. So there are two types of VNet peering. One is the peering between the two VNets of the same region. Say for example, here I am talking about the Western Europe region. So within the Western Europe only you have two virtual networks. Imagine you have another one in the Northern Europe, and here you have VNets. So if I want to establish between Western Europe and Northern Europe, if you create a peering, that is called as global VNet peering. So if you establish the peering between two different regions, this is called as global. Okay, so this is called as local VNet peering, and the below one is global VNet peering. Okay, so now you know by default no two VNets will have the communication, whether it is same region or between the region. So if you want to establish the connection between two different VNets, you should do one option called, you should enable one option called peering. That is called as Vnet peering. If you are enabling the peering between two Vnets of same region, that is called as local Vnet peering. If you enable the connectivity between two different Vnets of different region, that is called as global Vnet peering. Okay, and you may ask, Western Europe is a different country, Northern Europe is a different country. Will my connection is a secured one? Yes, because when you do the VNet peering, as I already told you, the communication passes via Microsoft backbone network by default. Okay, so Microsoft has laid down the cables between each and every region. Okay, they have laid down their own cabling between different region under the ocean, and any traffic that flows between the VNets or between the regions, it is secured. Okay, it is private. See, the network traffic between the peered VNet, it is private, and the speed is enormous. Speed is there, you don't need to worry about the speed. So very minute latency is there, you don't see the latency at all. Okay, it's a huge in size, huge in capacity. Okay, so it is very low latency and high end bandwidth. You can imagine terabyte wise copy data you can copy at a time. Okay, so high in bandwidth, low in latency. Okay, and ability to communicate and transfer the data across all the regions. No matter today your business is there in Western Europe or Northern Europe, tomorrow even if your business is coming to India, UK, US, or whatever regions across these 52 regions, every regions are interlinked with are interconnected using the Microsoft backbone network. So you have the ability of the data, or you have the ability of having the communication between any of the 52 regions, or if any new 50 uh, any of the not 50 to 54 regions, if 55th regions comes also, you can be able to have the communication also. Okay, and the data I've already told you, that's why I have written this symbol. So this symbol represents the data is end to end encrypted. How much encryption? Even Microsoft will not be able to see what data is processing. Okay, once you transfer, for example, you wanted to copy some data to this Vnet, and here you have created one storage box. So when you are writing the data, the messages will flow and it will come here and it will store here. Okay, so even Microsoft does not have visibility what data is stored inside their devices. They can only see some data is there, but what data, whether it is a plain text, whether it is a music file, whether it is some object, they will not be able to see at all. So it is your responsibility, okay, to store the data. Microsoft responsibility to ensure the data is end-to-end encrypted and the data is secured and you have the high availability also. Then for each and everything they will give multiple things, locally redundant, globally redundant, all these things they will give. Okay, that we will discuss later. Okay, and peerings, by default peerings are not transitive. I told you now, when you enable the peering, say for example you are in the Western Europe Vnet 1 and you are trying to establish a connection to Vnet 2, that time when you enable from Vnet 1 to Vnet 2, only Vnet when one computer can talk to the Vnet 2, but not Vnet 2 to Vnet 1, because it is not transitive. So transitive means it is two-way. I am believing you and you can also believing me. This is transitive. Okay, and I am believing you. It is not necessarily you should believe me. This is called as not transitive. It is one way. Okay, that is called as transitive and non-transitive. So transitive and non-transitive, it is nothing but the communication. It is unidirection or bidirection. So by default it is unidirection. If you enable from Vnet 1 to Vnet 2, only Vnet 1 can talk to Vnet 2, but not Vnet 2 to Vnet 1. If you want both, then you have to enable peering both the sides. You have to make it non-transitive. Sorry, you have to make it transitive. Okay, that's about the Vnet peering. Okay, so see here, that's why I have given, say for example, your 10.10.00/16, 192.168.1.0/24. If you enable the peering, okay, see, you can enable the peering. So some workloads is our VM01 and VM02. So when you enable the peering, so VM01 can talk to VM2. Similarly, if it is a transitive, VM2 can also talk to VM1 if it is transitive. If it is not transitive, only one way. And you see here, the network security group NSG is also created. So NSG created, and here also one NSG is there. There you will define what traffic should be allowed, whether it is 3389, whether it is DNS 53, whether it is HTTPS 8443, DSCP 6768, what all port connectivity you have to create that can be allowed. There are two things within the NSG: inbound rule and rules and outbound rules. There you can, by default, outbound is allowed everything, and inbound, only inbound we will restrict always. Okay, so this is the graphical representation. Now let us understand the classes. Maybe some people, you are not aware of the classes. Okay, IP addresses. Since I mentioned here two different IP addresses, and I am talking to have a separate classes altogether, let me also explain you about the classes of the IP addresses. See, in the IP addresses, we have 5 different classes. Okay, class A, class B, class C, D and E. These are the 5 classes of the IP addresses, and the class of the IP addresses will be identified based on the first octet, the first number of the IP address. So what class A tells you is, if an IP address that is beginning between 1 to 126, then call that as a class A IP addresses. Okay. Similarly, if you look at the class B start with 128.0.0.0 and up to 191. See, the continuity is there, 1 to 126. After 126, 127 is not there. I will tell you why it is. And after 127, 128 is there. Up to 191 it is. After 191, see, the class is starting with 192. 192 to 223. So after 223, it is starting with 224 and it goes up to this is 239. Okay, 239 and 240 to 255. So you see the continuity. So the IP address that is a valid IP will be always starting with 1 to 255. If you see, or if you just write an IP, say for example, if I am writing an IP address, let me go back to the OneNote. See, if I write an IP address, say for example, 192.168.1.100. If I ask you whether it is a valid IP or invalid IP, I can say it is a valid IP. Why? Because my IP address should meet some certain condition. What is that? The IP address should have 4 octet. Yes, it has got 4 octet. 1, 2, 3 and 4. 192, 168, 1 and 100. There are 4 octets because I am writing an IPv4. I am writing an IPv4. Okay, IPv4. It is a 32-bit logical address. It will have 4 octets. And each and every octet, the number should vary between 1 to 255. See, all the 3 conditions it is meeting. So 4 octets are there. Each octet is 8 bits, 8 for the 32-bit. So I am correct. My first condition is meeting. 4 octet, yes, 1, 2, 3, 4. It is 4 octet. And the number, if you see 1 to 255, see, the number is 1 between 1 to 192 is 1 to between 1 to 255. 168 is also between 1 to 255, and 1 is also between 1 to 255. 100 is also between 1 to 255. Okay. So my conditions, it is meeting. So it is a valid IP address. So now you may ask a question. I will not take much time. So you may ask a question, sir, why it is 1 to 255 only? Why it is not 256? If you write it 256 or 257, whatever number after 255, that is not a valid IP address. Because if you know basics of the IP address, okay, the IP address is nothing but it is IP address is nothing but it's a logical address of a computer, correct now? And computer will only understand zeros and ones, that you are already aware. Okay, even if you write 192.168.1.100, your computer will not straight away take this. It will convert this to binaries. Binaries means zeros and ones, zeros and ones. Correct na? And we are talking about the IP version 4. IP version 4 is a 32-bit logical address. 32-bit means what? Bit means it is 1. So bit means it is 1. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So this is total 32-bit. So we have divided as 8 octets. 8 plus 8 plus 8, 4 octets, sorry, 4 octets. 8 4s are 32. So 32 is my 32-bit is my IP address. Now if I take one octet, octa means 8. That's why we'll call it as octet. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there is a formula called 2 to the power of n minus 1. 2 to the power of n minus 1. So if you apply that formula, if you put 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, it is 1, 2, 4, 8, 16, 32, 64 and 128. If you sum up everything, it will be 256, and the formula is what? 2 to the power of n minus 1. So if you do 1, the maximum number comes to 55. That is why the number in each octet vary between 1 to 255. So if you write anything more than 255, or between 1 to 255, if you write more than 256 in any of the octet, that is an invalid IP address. Okay, that is why I was referring here. Okay, the number should be, the first number is always 1 and the last number should be always 255. Okay, so 1 to 126, if you write anything, it is a class A IP address. Between 128 to 191, if you write, it is class B address. Similarly, class C. So just to make you clarify your understanding, okay, I will write some IP address. You please tell me what class of the IP address it is belongs to. Okay, so class A is 1 to 126, class B is 128 to 191, class C is 192 to 223, right? So now you have to see only the first IP address, okay, and you have to tell me whether it is a valid IP and which class of the IP address it is belongs to. Okay, so now I will write one IP. You have to tell me whether it is valid or which class. 1.1.1.1. Can somebody tell me which class it is belongs to? Can you please repeat?
Class A valid.
Yeah. See, you see 4 octet. First condition is fulfilling. And you see each and every octet, the number vary between 1 to 255. So it is fulfilling both the conditions. So it is a class A valid IP address. Okay. And now tell me one more. 130.1.250.211. Which class it is? You should always see the first number to identify the class. then you should see all the octet if the number is vary between 1 to 255 to to tell whether it is a valid IP or invalid IP. So the first number belongs to the class B because the class B start with 128 and 191, between 128 and 191. So that comes in between here. So it is a class B, and see the numbers, everything is more than 1 and less than 255. So it is a valid class B IP address. So now let me give one okay, 200 dot 223 dot 255.1. Can somebody tell me which class it is, whether it is valid or invalid?
Class C valid.
Yeah, it's a class C valid IP address. Okay, so now we are able to tell whether it is a which class, whether it is valid or invalid. Now one more thing. Okay, 256.191.2.200, is it a valid IP? Which class it is belongs to?
Invalid IP, sir.
It's an invalid IP. Yes. Since it is invalid, you no need to tell which class it is. Correct, na? So you are able to identify. Okay, now you know how to identify the class valid or invalid. There are another two types of address are there, IP address. Okay. One is private, another one is public. Correct, na? So how to identify what is private and what is public, that is also important. Okay, so because private IP are free IP address, public IP is chargeable IP address. If you use private IP, your network will be secure. If you use public IP, your network will be in risk. So it is important to understand what is private and what is public. Okay, see, the first three classes can be useful. If you see this slide, class A, class B, class C can be used. See, can be used. They can be used. And class D and D you cannot use because they are dedicatedly kept for multicasting and research purposes. Okay, it is not usable IP address. We common mans cannot use this. Only the research and development peoples can use this. Okay. Since we use only these three classes, I should also know which is my private IP, which is my private public IP also. So they have dedicatedly kept in each and every classes one IP addresses. Okay. So in class A, it is 10.0.0.0. In class B, it is 172.16.0.0. In class C, it is 192.168.0.0. See, if you see any IP address that is starting with 10, starting with 172, starting with 192, then those IP we can call it as private IP. Okay, apart from these three numbers, if you find any number, that is public IP address. Okay, so now I'll write 2 3 IP addresses. Please tell me whether it is public or private. Okay, now I'm writing one IP address, 10.16.1.10. Is it a public IP or private IP? It is private IP because I'm writing the number with 10. Only the first octet you have to see, guys. Okay. So second one, 172.16.0.1. It is also private IP address. Now 192.168.100.200. This is also private IP address. Now you see, apart from this three number, you write anything like 1.1.1.1, 2.2.2.2, or 1.2.3.10, or 1.10.250.200, or you can write 193.168.2.10. Whatever number you have to see for the first number only. If the first number is not these three numbers, then we call that as a public IP address. Simple. Okay. So that is how you will identify whether the IP address is public or private. So the normally in the on-premises, either the first IP address or the last IP address of the subnet will be kept for the default gateway, the router IP address. But in the cloud, any network that you take, even if you create a small network or a subnet, /24 means it is 255 IP address are there. So out of, to see here, 10.0.0.0/24 means total 255 IP address it will give, because 10.0.0/24 means, the meaning of that is you are going to use 10.0.0.0/24 means you are going to use only one bit for the host, remaining bit for the network. That means your first IP address will be like 10.0.0.1, next IP address is 10.0.0.2, next one is 10.0.0.3, like that it will go up to 255. So total 255 IP address will be available, but in the cloud couple of IP addresses are reserved. You see here, 10.0.0 is your network ID. Anything that is ending with 0, that is a network ID. Okay. And 1 to 3 it is reserved for DNS purposes, and the last IP address is used for the broadcast purposes. Okay. So 5 IP address you cannot use in the cloud. So out of 255, only 250 IP address can be usable. You can assign that to the virtual machines. The first, like 10.0.0.0 is your network ID, and 10.0.0.1, 10.0.0.2, 10.0.0.3 will be dedicated or reserved for DNS. And the last IP of this subnet 00255 used for the broadcast. Okay, hence 255 minus 5, only 250 address can be usable. That is what I have mentioned here in the slide. Okay, so that's about the IP address. Any confusions or clarifications you need in the IP address? Because it's very important to understand the IP address and the networking concept. So if you know this much, it is enough for the Azure networking. Then we have other services, load balancer, traffic manager, all these things we can learn later. But this is the basics. Okay. So if you are done, I think we have covered with the theoretical portion. We can take any questions if you have. Otherwise, we can stop the recording and continue with the lab. I'm stopping the recording now. Thank you.